Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to be having a look at the wording of your exam questions. More specifically the words at the start of your question that will dictate how you answer the question and what the question is looking for. It's something that some students have some problems with, and as a teacher one of the most common questions I get is sir, I don't know what the question is asking me. How do I go about actually answering this question? So that's what we're going to try and focus on today. So today is the beginning of the maths questions. In my next video we'll have a look at the ending of the maths questions, and any words that I use today they will be in the description below, so if you want to copy and paste those into your own notes, please do fire away. Okay, just to start off, the majority of your questions, I've just taken an example here. This is an exam question from 2019, I think it was. We're not going to answer this today, but we're just going to have a look at, the breakdown of the wording of the question. So the majority of the questions have a command at the beginning. So that's what they want you to do. So in this question here, your command is to draw. And then some rules at the end, which I haven't read here. And those rules at the end, they're like your terms and conditions of the question. They give you a little bit of information about what your question could look like. And I think the hardest thing to do for students is just to sort of decipher what all those symbols actually mean. So you've got inequalities there, you've got X is an element of R, and if you don't know what any of those words mean, you might be in trouble. So I'm just going to park that bit there for the minute. Today we're just going to be concentrating on our commands at the start. So draw is obviously one of them. So in order to answer your question here down below, you should have, at the very end, you should have some sort of graph, some sort of curve, some sort of line drawn on your diagram there. So something like that. Once you have this done here, well, you'll know that you've answered the question. And whether it's right or wrong will depend on your knowledge of that topic, I suppose. So draw is one of the words you could be asked to do, but there are quite a few. I've written out quite a lot of them. I think I've gotten all of them. This is the first half of them here, the beginnings of your questions. And I've gone through exam questions or exam papers picking these out, but they're also at the front of your exam papers, a lot of them. So in the first couple of pages before you actually get onto the questions, a lot of these will be in the sort of index at the start. So it might be no harm to have a look at that as well. I've broken it up into two halves. So this is our first half, and then this is our second half. And I'm just going to walk through these bit by bit, I suppose. They could ask you to show something. And what show means is give an example where the statement is correct, and usually a formula from the log tables, in not only for the word show but for all of these commands, I suppose your log tables will help you out with that. So if you're asked to show something, you have to give an example where the statement is correct. The next one here sort of all mean the same thing: solve, evaluate, find the value of, work out, write down. Those 5 commands, it just means find the answer, and it's usually fairly obvious about, in the context of the question, what they're actually looking for. So they might be looking for the side of a rectangle, or they might be asking you to find out what X is in an algebraic equation. So there's usually an unknown value involved, so your X, and you're asked to find that out. If you're asked to expand, oftentimes with expand comes simplify as well. So expand and simplify, that's usually only used for brackets, so expanding your brackets. So just down here where I have room, you might be asked something like x minus 3 times x minus 2. And to expand those out means you're just multiplying your brackets by each other. Just rub that out just in case I need that space again. Find Tn. So if you're asked a patterns question, so what comes next in a group of shapes or a set of numbers, oftentimes they can ask you to find out what Tn is, and that's just the nth term. So you'd be used to finding out like what the first term is, the second term, the third term, but the nth term is like your rule to find out whatever term you want. So it's like a rule that works for every single term. Now the key thing here is if they're asking you for the nth term, you will have the letter n in your answer. So your answer will look like 2n plus 1, or maybe 3n minus 7, or minus 10n plus 25. The thing here is you will have an n in your answer. So a lot of those is to do with sort of like algebra and patterns and just sort of working with numbers and equations. Your first set of those there. Your next set, which I've sort of grouped together, are all to do with your constructions and your diagrams and sketching, I suppose. So I'll just go through these one by one. If you're asked to label something, and I have the question that we had at the start here. If you're asked to label something, let's say you're asked to label a point, and let's say your point is here. Now, I know it has nothing to do with the question there, but let's just say you're asked to label a point A, and that was your point. If you're asked to label something as A, make sure you do a nice big dot so that the examiner can see, and actually label it as the letter A. Do it nice and big so that the examiner can see, and make sure it's on your diagram so that you get your full marks. If you just say that like A is on diagram, but you don't put it in, I cannot give you the marks as an examiner. So make sure you do exactly what the question is asking you. We have label. If you're asked to sketch something, it's just draw it roughly. It doesn't have to be perfect. You don't have to use your ruler or your compass. You can if you want, but you don't have to. So if you, for example, were asked to draw a right angle triangle, you could do something like this. And obviously, like my lines here are quite squiggly. That right there looks like, this here looks like a right angle, but it could be maybe 89 degrees. It's not exactly right angled. If you're asked to sketch a right angle triangle, just put in the little square down here in the bottom corner to indicate that that's the right angle that you're working for. And in regards to question, that's absolutely fine. Like even if you drew something like that, that would get you your full marks for it. Doesn't have to be perfect, but it should resemble what's in the question. If you're asked to construct something now, that's nearly the exact opposite. You have to be like really, really precise with what you're doing. In Junior Cert, you have 15 constructions to know, and I'm going to link those below in the description as well if you want to familiarize yourself with those. The big thing here is you need to use your ruler, use your compass, use your pencil. Show me your construction lines as well. Don't rub anything out. You shouldn't, if you're constructing something, you shouldn't really be doing that in pen in case you make a mistake. Yeah, so just in general, constructing something is a lot more accurate than sketching something because you're doing it with all the proper equipment. If you're asked to graph or draw something, graph and draw mean nearly the exact same thing, usually to do with functions questions. You'll be given a function and asked to graph it or to draw it. And basically what that means is draw a picture of what the function actually looks like on a diagram. So you might have like, I'll just rub out my right angle triangle here. You might have like f of x is equal to 3x plus 2. And obviously that's just numbers. That's just like a function telling you what it is. But in order to draw it, like your x and your x-axis and your y-axis, that right there would be a picture of what's going on. Now I know that was very, very rough. I didn't have a lot of space there, but I hope you get the idea of what's going on there. Okay, following on from that, if the question asks you to use the graph to do something, this is important. And I'll go back to this question here. So just so we're clear, this bit here is the question and this bit here is the marking scheme. So if you're asked to graph something, then you should end up with something like that there. But if you're asked to use the graph, let's say to use graph to find out what is y? What is y when x is 1? If you're asked to use the graph, then I need to see some construction lines on your actual graph here to show me as an examiner that you used your graph to get your answer. So in order for this, this is my x-axis here, the horizontal one. If I was to draw a line up to my graph here, it would hit it about there. And if I was to draw a line horizontally across from that, it would hit it just below 10, and I would say that would maybe be about 7. But the point here that I'm trying to make is, if the question asks you to use your graph to do that, I need to see these little dots here on your actual graph to show me as an examiner that you have used the graph to get your answer, because sometimes there's other ways to get your answer without using the graph, but that's not what the question will be asking you. If they ask you to use your graph, you need to actually use the graph. Just in regards this question here, I have a functions video done as well, so I'll link that below if you're not okay with graphing functions. I'll link that below, and also there's a way to do this question on your calculator as well that cuts out quite a lot of work for you, but you do have to be 100% clear on what you're doing with your calculator method in order to get your full marks, because one mistake with your calculator and all of a sudden you'll go from having all your marks to none of your marks. So I'll put those two below, how to do it manually, my actual video, and then the video on the calculator as well, how to do that question, if you are interested in that. I think we had one more question, or one more word to have a look at. Oh, prove. So prove is used for your geometry theorems, and there's 5 of those. And there's a set way of doing those. They give you a set of instructions on what to do for your proofs. So like the layout of your question won't change, but the proof, they'll pick 1 out of the 5. And I'll put a link to those below as well. Just as a side note, on those proofs, you can learn them off if you want, just learn them off word for word, but it is very satisfying when you can see where they're coming from, or when you get it out and you can see why your proofs actually work. So that's just a side note on your proofs. If it asks you to prove something, chances are they're talking about your geometry theorems, and you need to have those nailed on, because one of those nearly always comes up. Okay, that's the first half done there, and we've sort of looked at algebra and geometry. The next ones here sort of get into the more meatier questions, I suppose. So sort of like the second half of a question. If a question is broken up into 2 parts, sometimes they'll ask you a second part of a question, but you might need the first part of your question to help you out. So if it asks you hence or otherwise, then they've asked you a starter question and you might have gotten that. And if they ask you hence or otherwise, that means they're asking you another question based on the first part, and basically you can answer that any way you want. It's sort of like the opposite of, well, not really the opposite, but it's linked to the word hence. If it says hence, that means like following on from. So if it says the word hence, you have to use what you used in the previous part of your question to get your answer. If it says hence or otherwise, then you have an option. You can answer that part of the question whichever way you want to. And just what I've written here, if it says hence or otherwise, you can use the previous parts of the question. That's usually easier to do. Okay. Explain and justify. I'm just going to group those 2 things together because they sort of mean the same thing. It just means give a reason for. And usually a mathematical definition will help you out with not just the word explain, but with justify as well. So these 2 are very, very similar. Basically, you're just backing up your answer. Sometimes like a few sentences in English will actually help you out with that. Other times you might have to give a mathematical definition, and I have an example of one of those just after the next couple of definitions here. So that's explain and that's justify. If they ask you to verify something, that just means to prove that your answer is correct. So usually with that, it'll be some sort of algebra equation, and you will have got your answer for x at the end. But you have to make sure that your answer is correct. So let's say, and I'll use the space just up here at the top beside my bit emoji. If you had x plus 2 is equal to 7, and if you're asked to solve that, we'd take 2 away from both sides, and we would get that x is equal to 5. And I'll just put a square around that. So that would be my answer to my part I of my question. If they asked you to verify that your answer is correct, what you would do is you would take your answer, your x is equal to 5, and you would put it back into the question that you had at the start. So if your answer is correct here, and if you put it back into what you had at the start, then your starting equation should make sense as well if you've done everything correct all the way down. So just down here at the very, very bottom, if I was asked to verify that that was correct, well, I'd say I got x is equal to 5. So my 5 plus 2 is equal to 7. Now let's see, does that make sense? Well, 5 plus 2 is 7, is equal to 7. 7 is equal to 7. Of course, that's correct. So you have shown now that the answer that you got in the first part of your question, your x is equal to 5, it works for when you're verifying the question. So that's usually where that comes up. Obviously your question will be a small bit harder than x plus 2 is equal to 7. You might be asked that for maybe a simultaneous equation, just for example. So if you're asked to verify something, get your answer and just make sure it works for the original question. The last two here, round and simplify, that's sort of like the ends of your questions, like when you get your answer, how they want your answer to look like. So if they ask you to round it to, like if your answer is, let's say, pi, you know that pi is equal to 3.14159, and then there's a few more after that. If they ask you to round it to 1 decimal place, that would be 3.1 to 1 decimal place. If they ask you to round it to 2 decimal places, it'd be 3.14, and so on. Just be careful at the end there, because it'd be an awful shame to get your answer and to leave it as pi if they asked you to round it to 1 decimal place. Oftentimes there's 1 mark being lost for not putting the answer in the right form. So if you think about that in terms of the whole exam, 1 mark for each question, that's roughly, if you took every question, is roughly about 10 marks. And if you're losing 1 mark in each question, that's only like the maximum you can get there. If you get everything else absolutely spot on, is 90%, which basically rules out your A, I suppose. So I suppose, yeah, the point I'm trying to make here is, if they ask you to round it to a couple of decimal places or significant figures, do exactly what the question is asking you. If they ask you to simplify it, the same thing. Give your answer in its simplest form. Don't leave your answer as, let's say, 2/4, because you know you can simplify that to a half. I will be doing a small bit more on this in my next video, which is about the endings of questions, like your terms and conditions at the end. But right now, just to finish off, so this question didn't come up in any exams or anything, but I just sort of took it as there was a question very similar to this that came up in a mock paper that I was marking a while back, and I just wanted to show you where some students went wrong with that. So triangle has sides 3 centimeters, 4 centimeters, and 5 centimeters. Is it a right angle triangle? And you got to justify your answer. So right now I'm just going to sketch what a right angle triangle should look like. And if it's a right angle triangle, my longest side should be the 5, this should be 3, and this should be 4. If it is a right angle triangle, the 3, the 4, and the 5 should fit into Pythagoras' theorem. So a squared plus b squared is equal to c squared. Now let's see if that holds true. So my two smaller sides should be my a and my b. So 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. If we look at the left hand side here, 9 plus 16 is 25. 25 is equal to 25, and we are done. A lot of students stopped there, and out of the 10 marks, you would only be getting 5. In the mock paper that I was looking at, you would only be getting 5 marks for doing all that work, for the reason that you did not answer this part or this part of your question. You gave me all your hard work, you did the hard work, and you gave me all your workings out, and that's like really, really good, but you did not say yes or no. So if someone asks you, like, is something a right angle triangle? If someone came up to you in the street and asked you, is that a right angle triangle? You would say yes, or you would say no. Nothing changes when you come to an exam. You have to give me an answer, because right now you haven't said yes or no over here. You've given me all the working out, but you haven't explicitly told me. So first of all, you've got to tell me, is it a right angle triangle? Well, yes, it fits Pythagoras' theorem. And that's exactly what you need to put down in order to finish off the question and to make sure that you get your full marks. So literally writing down yes. That answers, is it a right angle triangle? That's nearly worth another 3 marks. And then to justify your answer, the 3 sides fit Pythagoras' theorem. Pythagoras' theorem. Or if you were feeling fancy, you could say the 3 numbers are a Pythagorean triple, which means the same thing. But anything along the lines of the 3 sides fit Pythagoras' theorem. That right there is your justification. Justification. This right here is answering that part of the question, and this right here is your working out. So between this part here, and this part here, you've gotten your full marks. So what seems like a fairly standard question, you just need to make sure that you're actually answering the question that they asked you. So I always tell my students, like, read the question, and like, I've no doubt that you can all read what those words actually are, but actually answering the question that's asked is sometimes a different story altogether. Yeah, so read the question, and more importantly, answer the question asked. Even saying just yes there might have gotten you a few marks as well, even without these 2, because you've actually answered the question and you are correct. The workings out and the justification will get you like all your marks, obviously, along with the yes. But if you had yes on its own, you've answered the question, and you might even scrape the barrel. You might be getting 3 or 4 out of your 10 marks for that. So just something to be aware of. Okay, I'm going to finish up there. As I said, any links or definitions will be in the description below, and just keep an eye out for my next video, which will be about ending a maths exam question. So if we just go back to the start, like the rules at the end of your question. So that part there, what that actually means, and how you would use that to help you out in a question. All right, guys, thanks for listening.